Welcome to Statistically Speaking with Dr. El Bayoumi, where we turn numbers into knowledge. Today's topic sits at the heart of modern data science, public policy, and ethical responsibility, privacy, and big data. This is not just a technical discussion, it is not just a legal discussion, and it is certainly not just a theoretical discussion. Privacy in the era of big data is a societal, ethical, political, and statistical challenge, and one that every data scientist, analyst, and researcher must confront. As graduate students, you are no longer just consumers of data, you are becoming stewards of data, and with that stewardship comes responsibility. Let me begin with a historical perspective. In the 1960s, long before smartphones, cloud computing, or artificial intelligence, Paul Baran issued a warning. He argued that large-scale digital systems would eventually store highly sensitive personal and business information, and that the only thing preventing abuse was trust or, as he put it, a lack of technical sophistication among potential eavesdroppers. Fast forward to today, trust is no longer sufficient. Technical sophistication is everywhere, and data collection is no longer limited. It is continuous, invisible, and deeply embedded in everyday life. Every search query, location ping, biometric scan, purchase, swipe, click, and pause contributes to a growing digital profile. Big data does not merely observe behavior, it models, predicts, and influences it. Privacy, therefore, is no longer about secrecy, it is about power. Before we talk about privacy risks, we must be precise about what big data actually is. Big data is typically characterized by the 5 Ds: volume, massive quantities of data; velocity, data generated and processed in real time; variety, structured, semi-structured, and unstructured data; variety, uncertainty, noise, and bias in data; and value, economic, political, and strategic utility. From a statistical standpoint, big data often violates traditional assumptions. Data are not random samples, they are exhaustive, opportunistic, and behaviorally generated. From a privacy standpoint, these characteristics introduce serious concerns: re-identification of individuals, inference of sensitive attributes, and secondary and tertiary uses beyond original consent. Privacy risks scale nonlinearly with data size and linkage. One of the most misunderstood aspects of privacy is where data actually comes from. Many people assume that data collection happens only when they explicitly provide information. This is incorrect. Modern data ecosystems include social media platforms, mobile applications, Internet of Things devices, wearable health technologies, financial transactions, public records, government databases, and data brokers. Data brokers in particular deserve attention. These entities aggregate information from public records, property ownership, court filings, and voter registrations, and combine it with commercial and behavioral data. The result is a detailed, continuously updated digital dossier, often created without the individual's knowledge and sold without meaningful consent. From an ethical perspective, this raises a fundamental question: can consent be meaningful when individuals do not understand the scope, permanence, or downstream uses of their data? Privacy is often framed as a personal concern, something individuals should manage through settings and choices. This framing is dangerously incomplete. When corporations and governments collect, share, and analyze population-scale data, privacy becomes a collective concern. It affects freedom of expression, political participation, economic opportunity, and social equality. Large-scale data analytics can be used to nudge behavior, shape opinions, and segment populations in ways that are invisible to those affected. From a statistical ethics perspective, this is deeply troubling. Models trained on behavioral data do not just predict outcomes, they can reinforce structural inequalities and manipulate decision-making processes. Privacy, therefore, is not merely about protecting individuals from embarrassment or harm. It is about preserving democratic agency. Historically, privacy protections relied on 3 assumptions. Data collection was limited, data use was purpose-specific, and data storage was costly and temporary. But none of these assumptions hold today. Modern big data systems include collect data continuously, repurpose data indefinitely, retain data indefinitely, and combine data sets across domains. Traditional mechanisms such as notice and consent models are insufficient. Privacy policies are lengthy, vague, and rarely read. Opt-out mechanisms shift responsibility onto individuals who lack bargaining power. From a research ethics standpoint, this is equivalent to systematic coercion. The ethical roots of privacy can be traced back to the seminal work of Warren and Brandeis in The Right to Privacy, where they argued for the right to be let alone. In the digital era, being let alone is no longer realistic. Instead, modern privacy ethics focus on autonomy, dignity, contextual integrity, fairness, and accountability. For data scientists, this means asking difficult questions. Should this data be collected at all? Is this variable necessary for the analysis? Who benefits from this model and who bears the risk? What harms might arise from misuse, re-identification, or inference? Ethics is not an afterthought, it is a design constraint. One of the most contentious privacy debates is the right to be forgotten. This concept allows individuals to request the removal of personal information that is outdated, irrelevant, or harmful. From a transparency perspective, especially for public figures, this raises concerns about accountability. From a privacy perspective, it acknowledges that data permanence can unfairly penalize individuals for past actions. For statisticians, this introduces methodological challenges. How do we handle missing or removed data? What happens to models trained on deleted information? Can historical bias persist even after data removal? Privacy is not just a legal issue, it affects model validity and fairness. Some technology companies have introduced privacy initiatives such as transparency labels and user dashboards. While these are positive steps, they often fail to address deeper structural issues. Asymmetric power, profit incentives tied to data extraction, and a lack of independent oversight. Transparency without accountability is insufficient. Ethical data practice requires governance, not just disclosure. Let us now turn to solutions, particularly those relevant to data scientists. One promising approach is differential privacy. Differential privacy introduces carefully calibrated noise into data or query outputs to ensure that the inclusion or exclusion of any single individual does not significantly affect results. This allows population-level analysis, protection against re-identification, and formal privacy guarantees. Other important techniques include encryption at rest and in transit, secure multi-party computation, federated learning, data minimization strategies, and access controls and audit trails. However, no technical solution is sufficient on its own. Privacy must be supported by organizational culture and ethical leadership. As graduate students and future professionals, you will face pressure to collect more data, build more complex models, and deliver faster results. You must resist the idea that more data is always better. Ethical data science requires clear problem formulation, justified data collection, transparent assumptions, and responsible communication of results. Privacy-aware data science is not a weaker science. It is better science. The future of big data will include artificial intelligence at scale, biometric and genomic data, predictive policing and risk scoring, and automated decision systems. Without strong privacy protections, these technologies risk amplifying inequality, eroding trust, and undermining democratic institutions. Privacy is not an obstacle to innovation, it is a precondition for sustainable innovation. Let me leave you with this final reflection. Privacy is not about hiding wrongdoing. It is about protecting the space in which human freedom, creativity, and dignity can exist. As statisticians and data scientists, we are not neutral technicians. We are participants in shaping the future of information society. The question is not whether big data will continue to grow, it will. The question is whether we will have the wisdom and the courage to use it responsibly. If you found this helpful, don't forget to like, subscribe, and click the bell to stay updated on all things data, and statistics. Thanks for watching.